Objective 2. So we're going to dive into parabolas with different equations other than the basic parabola or parent function y equals x squared, and then compare the new parabola that we plot to the beginning parabola or the basic parabola that you did in Objective 1. Objective 2 is discussing vertical shifts of a quadratic function. So hopefully you can start predicting what is going to happen if given these types of quadratic functions. So let's begin. The investigation number 1. If I was going to model this, I would first notice that I can consider this function here, y equals x squared plus 2, to be in vertex form. Again, vertex form is y equals x minus h squared plus k. So I'm going to plot all the points on my table of values there, but I also want you to be able to develop the skill of noticing the locations of an h and a k in the given function. In this case, y equals x squared plus 2. You notice h is to the left of the power and k is to the right. So the number, any number that exists to the left of the power is h. And if you remember, h's are the x values, k's are the y values. I know it's confusing with all the different variables, but please just make note of that. So if you see in our given formula or function here, there is no number to the left of the power. There's no number to the left of the power of 2, the quadratic term there. So I know that the h term is 0 because it doesn't exist. So I know that my vertex is going to have an x value of 0. Now, to the right of the power is the number 2, a positive 2. So I know that at 0 comma positive 2 is going to be my vertex. Now that won't always be the case. 0 won't always be the x value, but in this case it is. And I need you to start developing that skill of, if given a function, can you locate its vertex instantly? Because then if you remember the step pattern, over 1, up 1, over 1, up 3, over 1, up 5, you can plot any parabola based off of its vertex. So I want to work backwards like that. And I'll do that more in the investigation number 2. But that's the goal, hopefully, by the end of this, because it's much easier just to work with the vertex. Let's go ahead and plot the rest of these points. I'm going to plot 0, 2 for the vertex right now, right there. And then let's try negative 1. If I put negative 1 into my function up here, let me erase now all the beautiful colors I drew. If I put negative 1 in there, I get y equals negative 1 squared plus 2, which is negative 1. If you put it in parentheses, you can put that exactly like that in your calculator. Negative 1 squared is 1, plus 2 is 3. So negative 1 comma 3. If I put negative 2 in there, negative 2 squared is 4. 4 plus 2 is 6. And I put negative 3 in there. Negative 3 squared is 9, plus 2 is 11. Same thing. If I put 1 in there, my outcome would be 3. If I put 2 in there, it would be 6. And 3 is 11. So from the vertex, the purple dot that I pointed on the graph, I'll go back to purple. Let's plot the rest of the points. Negative 1, so over 1 from the vertex. Actually, I'm going to, so the vertex is here. Now all these other plotted points are in relation to the vertex. I go over 1, up to 3. Let me backtrack. No, all these points here are in relation to the origin, 0 comma 0. It's still over 1, up 3. Now, over 2, up 6. 1, 2, 3, 4, 5, 6. And then over 3, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And same thing over here. So over 1, up 1. Over 2, up 6. Over 3, up 11. And there is my parabola. So again, if plotting the points from the table, they're all based off of the origin. But what I did initially was I plotted the vertex 0, 2. So what you can do then is, if you notice, if you've plotted the vertex 0, 2 right here, you can use the step pattern down here from the vertex. And if you notice, they all line up. If I go over 1, up 1, there's the dot that I already plotted off my table. Then from there, over 1, up 3, 1, 2, 3. There's that dot that I plotted from my table. Then over 1, up 5, 1, 2, 3, 4, 5. So the step pattern, that's why I want you to get in the habit, over 1, up 5, of finding the vertex first, and then you can use the step pattern. Always. If you want to use the table method, that's fine, but I'd much rather you get in the habit of finding the vertex and then using the pattern over 1, up 1, over 1, up 3, over 1, up 5. So if you would now, try parabola investigation number 2 on your own. Try, if you would, to find the vertex based off of the information, the function that it gives you. Once you have the vertex, try to use the step pattern. When you've done all of that, please raise your hand and I will come check your work.